Fractions can be split up into 3 topics. So we've got improper fractions. This is where our numerator, the number on top, is larger than the denominator. The second topic is fractions of numbers. So this could be, for example, finding the fraction of students with blonde hair or something. And the third topic is arithmetic. So adding, minusing, timesing, and dividing fractions together. So let's look at the first topic, improper fractions. This is most often seen in the context of mixed numbers. So, for example, let's look at 7/3. So we could convert this into a mixed number, and by mixed number, I mean a number that is a mixture of a whole number and a fraction. So it has that kind of a format to it. And so in this example, all we're doing is, we're basically doing 7 divided by 3, right? So we want to find how many 3's go into 7. Well, there are 2 whole 3's in 7, so we can put a 2 there. And then what's left over? We've got one, a kind of remainder 1, because 2 3's gives us 6. We want 7, and so we've got a remainder of 1. So that 1 is still divided by that 3. Another way to think of it is that 2 is also, it's essentially 6/3, isn't it? That's what's giving us that 2. And because we need 7/3 in total, we've got this 6/3, we need to add on an extra third. And likewise, we can go back the other way as well. We can be given a mixed number, and we can go back the other way. So we could think of that 2 as 6/3, add on, add that 6/3 with that 1/3, and we can get back to that 7/3 again. So we can flip between the two types of fractions. Next up is fractions of numbers. So if we just look at this example, a fifth of 40. Well, on the calculator, we would need to do 40 times a fifth, or a fifth times 40. And 40 times a fifth, well, we could think of this as actually 40 over 1 times 1 over 5. And when we times fractions together, we'll do it in a second with arithmetic, all we do is we do top times top and bottom times bottom. So we end up doing 40 times 1, which is 40, and we do 1 times 5, which is 5. And so 40 over 1 times 1 over 5 gives us 40 fifths. And this is basically 40 divided by 5. So that's the kind of takeaway there. We can either times by a fifth, or we can look at this and we're basically doing 40 divided by 5. And they're the exact same thing, right? They're kind of interchangeable ways of thinking about the same problem. And with arithmetic, well, just for a second, I'm going to write this as 5 over 1. And as I did up here, I'm going to write this as 40 over 1. Because what we can see instantly when we start to tackle division is we can either divide by 5 over 1, like we're doing here, or we can times by 1 over 5. And they're the exact same thing. So if we can do multiplication with fractions, we can actually do division, because we just flip that fraction around and we're able to turn that division question into a multiplication question. So whenever we have, just to do one more example, let's say we've got 5/6 divided by, 2/7. Well, this is the exact same as 5/6 times 7 over 2. And again, when we have this same problem, we just do top times top, bottom times bottom, we get 35 over 12. So that's division taken care of, that's multiplication taken care of. Adding and minusing is slightly trickier. Adding, we have to make sure we have the same denominator. So let's stick with this. Let's do 5/6 plus 2/7. Well, in this case, I can't add 6ths and 7ths together. They're two separate things. So what we need to do is we need to turn these two fractions into two new fractions that have the same denominator. So I need to have the same number here as I have here on the bottom of my two fractions, and I'll have two different numbers on top. Well, the trick we can do is we can take this whole fraction and we can times it by 7, by that denominator. And what we end up with is 5 times 7 on the top, which is 35. And we end up with 6 times 7 on the bottom, which is 42. The next thing we do is we take this whole fraction and we times it by this denominator. We times it by 6. So we do that. And what we end up with is the exact same number on the bottom, because again, we're doing 6 times 7 to get our new denominator, which again is 42. And we do 6 times 2 on the top to get 12, because whatever we do to the bottom, we have to do to the top. And what we can see now is we've got the same number on the bottom. So now we're doing 35 42ths plus 12 42ths. I don't know if that's the correct way of saying it or not. We end up with 47 42ths, probably tooths. And that would be our final answer. So that's how we add. And minusing is the exact same. Again, we need to have that same denominator. Right, let's go on and look at some exam style questions. So we'll go back to our topic 1 and do a practice question on this. So we're doing 1 3/5 divided by 3/4. Well, I don't want to do 1 3/5. I want to convert this into an improper fraction. So at the moment, this is a mixed number. And I'm going to write this as 1 plus 3/5. There's a kind of an imaginary plus sign between these two that we don't normally write, but it is there because we are just combining these two numbers together, this number and this fraction. And I'm also going to write this 1 as 1 over 1. Well, you'll see a 1 in a second, because what we end up having now is a fraction plus a fraction. Well, we know how to do that, right? We just need to times this whole fraction by this denominator, and then we times this whole fraction by this denominator. Well, 1 times 5 is going to be 5. 1 times 5 is going to be 5. And this whole fraction times 1 is just going to stay the same, right? 1 times anything is just itself. And so we can now work out the total value of this. 5/5 plus 3/5 is going to give us 8/5. And this question then becomes 8/5 divided by 3/4. Well, we've seen that we don't really want to do a division. We'd much rather do a multiplication. So what we can do is we can flip the top and the bottom around and turn it into a multiplication. So this becomes 8/5 times 4/3. And we just do top times top, bottom times bottom. 8 times 4 gives us 32. And 5 times 3 gives us 15. And that's our answer. Moving on to topic number 2, fractions of numbers. If a class has 29 students and 16 of them are girls, what fraction of the students are boys? So we're going to assume that all the non-girls are going to be boys. So we're going to say, if we're starting off with 29 and we're subtracting the 16 girls, we're going to be left with 13 boys. And as a fraction of the total, well, that's just 13 out of 29. And that's our answer, 13/29. Moving on to the final topic, arithmetic. We'll do an adding one first. So 1/3 plus 1/12. Well, as we've seen before, right, we need to make sure that these two numbers, our two denominators, are the same number. We can't just add thirds and twelfths together because they're different things. And what we can do is we can, if we're smart about this, rather than timesing this whole fraction by this denominator and this whole fraction by this denominator, we can take a shortcut and we can just times this first fraction by 4, the top and the bottom by 4. And what that's going to give us is 4 on top and 12 on the bottom. And we've all of a sudden we've gotten to our two same denominators. Yeah, we could have done the old method. We would have ended up with 12 over 36 plus 3 over 36. But it's just slightly quicker this way. And 4/12 plus 1/12 is going to give us 5/12. Right, final question. 3/4 times 1/5. 3 over 4 times 1 over 5. We just do top times top, bottom times bottom. We get 3 over 20. And it is really simple as that. Timesing fractions is counterintuitively the nicest one to do. And that is the end of all fractions.